Okay guys, we're continuing with trigonometry. We're essentially doing the same exact thing we did 2 days ago, but the numbers are going to get a little more complicated. There'll be some radicals in here, and then also when we get to the second page, you're going to actually have to do the Pythagorean theorem, if you can believe that. So this is the extent of it, 12 problems, so 6 that you'll have to do, just being the odds. All right, so you can refer back to the previous lesson for the actual ratios. I'll throw them out there as we need them. On the last assignment, I made sure there was at least one of each. Here it's just kind of random. So number 2 here starts with secant. And secant is defined as hypotenuse over adjacent. Hypotenuse over adjacent. So if we look here, theta is down here. The hypotenuse right here, adjacent is 12. It's the one touching the theta. So we need to make a ratio out of these two things. So put down a fraction bar. Hypotenuse goes on top, 6 radical 13. 12 goes on the bottom. And then you can reduce this fraction. Now you can reduce non-radicals with non-radicals, or radicals with radicals. So the 6 and the 12, both non-radicals, we can reduce those both by 6. We get 1 radical 13, which is just radical 13 over 2, and then that should be the answer. Let me check number 2, and there it is. That hopefully wasn't so bad. The fact that there's a square root or a radical in there wasn't a problem. As we go through, it'll get a little more complicated as we go. Number 4, a cotangent problem. So cotangent, if you check your notes, was defined as adjacent over opposite. So here's theta. Our adjacent, that's the hypotenuse. Our adjacent is this side, 12. And the opposite, the one across from theta, is over here. The other side, the hypotenuse, but that's kind of irrelevant. You don't really need to worry about that. So we need to make a fraction out of this. Put down a fraction bar. Adjacent is 12 on top. Opposite is 12 radical 3 on bottom. And hopefully you see that the 12 over 12 will reduce down. 12 divided by 12 is 1, and you get 1 over radical 3. But then we come back to a rule of algebra that we haven't talked about in a while, and that's the fact that you're never allowed to have a radical or a root in the bottom of a fraction. And there is a method for fixing this. It's called rationalizing. And you simply multiply this fraction by whatever that radical is on top and bottom. On top, 1 times the square root of 3 is square root of 3. On the bottom, square root of 3 times square root of 3 is square root of 9. But you can do square root of 9. You can simplify that. The square root of 9 is 3. So this answer has now the radical on top, which is okay. You can't have the radical on bottom like up here, but you can have it on top. So that should be the answer to number 4. Let's check and see. Yes, and there it is. Now, we did go over briefly a little shortcut to this process. So let me start from this step right here. And if you want, to know how to sort of skip this, here is a shortcut. Okay, move the radical to the top. Whatever's already on the top stays there. And then on the bottom, you just rewrite the number that's under the radical bar. And then in this case, 1 times radical 3, that 1 really is irrelevant. And you get the same answer. So you move the radical to the top and then get rid of the radical sign on the bottom. I'll probably do this shortcut a couple more times. It's just for your own interest. You don't have to do shortcuts. It's just if it makes sense to you. All right, number 6 is another cotangent problem. Again, this is just random order. So adjacent over opposite. The adjacent to theta is here. Let me write that down. The opposite is across from theta over there. So let's make a fraction out of this. Adjacent is 9 over opposite, 4 radical 13. Nothing will simplify here. You can't cancel the 4 and the 9 or anything like that. So we just need to rationalize, get rid of the radical in the denominator. So here's the step-by-step method, and then I'll do the shortcut. So you need to multiply by square root of 13 over square root of 13. On the top, 9 times square root of 13 is just 9 times the square root of 13. On the bottom, we have 4 square root of 13 times square root of 13. That's going to be 4 square root. 13 times 13 is 169. So that's 9 radical 13 over 4. Now, what is the square root of 169? Oops. Let's see. I got to get Desmos up here. I mean, I know what the answer is. I'm just kind of playing devil's advocate. Like, what if you didn't know? What would you do? Excuse me. So I'm right here. Square root of 169 is 13, of course. But then you've got 4 times 13 on the bottom. So 4 times 13 is 52. 9 radical 13 on top. 52 on the bottom. And that should be the answer to number 6. And there it is. Okay, let's look at the shortcut. So I'm going to start from this step right here. Adjacent over opposite. Okay, so move the radical to the top. Whatever's already on top stays there. And then the bottom, well, since there's already something on the bottom, that stays there. But then just get rid of the radical sign. So you move this up here and then get rid of the radical and just bring the 13 over. And then, as you can see in the calculator, 4 times 13 is 52. 9 radical 13 over 52. So same answer, a lot less work. All right, so 1, 3, and 5 are like that. So you need to have your ratios. So the notes from yesterday would be good. Pull that video back up if you need to and take a screenshot. And as you do these, no radical left in the denominator. You can't have that. Okay, the next side is a little different in that one of the measurements is missing in each diagram. So you have to deal with that. It looks like, oh, all 3 of my examples are sines. Tell you what, maybe I'll do 8, 9, and 12. That way I'm not doing the same type of problem every single time. I think that makes sense. And then I'm going to ask you to do number 10 instead of number 9. So when I say do the odds, I mean do the odds, but also do number 10. Don't worry about number 9. I'll do that one. Okay, so what is sine? Sine, SOHCAHTOA, is opposite over hypotenuse. The opposite side is over here. Oh, that's good. The hypotenuse is right here. This side is irrelevant anyway, so who cares? So opposite over hypotenuse is 12 over 15. You can reduce 12 over 15, divide them both by 3, you get 4/5. So number 8, the answer should be 4/5, and there it is. Let's look at number 9. So I'll do 9. I'm assigning 10. Okay, cosecant. Cosecant, check your notes, is defined as hypotenuse over opposite. The hypotenuse on number 9 is right here, and the opposite is over there. So we need to know what the hypotenuse is before we can go any further. So this takes us back to geometry. Remember, a squared plus b squared equals c squared, where c is always the hypotenuse. So we have to do 24 squared plus 16 squared equals c squared. Let me do, on the calculator, 24 squared plus 16 squared. I get 832 equals c squared. So c is going to be the square root of 832, and look at that. You get a decimal, one of those decimals that goes on forever that nobody likes. So I'm going to have to simplify 832. All right, 832 is an even number, so I know I can divide it by 2. 416 is also an even number, so I know I can divide that by 2. 208 is an even number, that's 104, which is an even number, that's 52. 52 is 2 times 26, and that's 2 times 13, and 13 is a prime number. So how do we simplify radicals? We got one pair of 2's, a second pair of 2's, a third pair of 2's. So that's going to be, running out of room here. Square root of 2 squared times 2 squared times 2 squared times 13. Let me see if I can make that a little bit neater. Remember, the square root and the squares cancel out, so I can cancel out this one, this one, this one. That means I can bring out 1, 2, 3 2's with a radical 13 left over, so that's 8 radical 13. So the hypotenuse of this triangle is 8 radical 13. Cosecant is hypotenuse over opposite, so the cosecant of theta, what I'm going to do right now, hypotenuse over opposite, that's 8 radical 13 all over 24. And then the 8 and the 24, you can simplify that. Divide them both by 8, you get 1 and 3. That's radical 13 over 3. So there are a lot of skills that go into this one problem. This is one of the reasons we learn so many skills in Algebra 2 and in geometry. So geometry, the Pythagorean theorem, that's a thing you have to do. When you get to this point, you go to square root it, and you see an irrational number on your calculator, the 28.8444102, blah, blah, blah. You can't use that number, so you have to simplify the radical. We spent a lot of time, obviously, on this whole process, simplifying radicals. So you do that. That gives you the simplified hypotenuse. Plug that into your trig ratio, and then reduce the fraction if you can, and there you go. So number 9 was pretty complicated. Number 10, the one that you're going to do, since it's even, I did an odd one, it's going to be pretty similar. You're going to have to do the Pythagorean theorem to find the hypotenuse, simplify it, and then work it out a lot like I did. Hopefully it's not 832. Yeah, the numbers are a lot smaller. 3 and 9 are easier to work with than 16 and 24. So you're probably still going to have to do the tree diagram over here to work that out, but it should be smaller numbers, so not quite as bad. Okay, I'll do number 12, and then we should be done. So number 12 is another sine problem. It could be secant, cotangent, whatever. Just check your ratios. Again, sine is opposite over hypotenuse. The opposite over here is missing. The hypotenuse is 4 radical 13. So we need to use a side that's missing. So once again, we have to do a squared plus b squared equals c squared. So the opposite I'll leave as a squared. B squared is going to be 12 squared equals c squared. So now I have to take this and square it. So what's going to happen here? A squared plus 12 squared. 12 squared is 144. Use a calculator if you need to. Here I have to square both of those. So what's 4 squared? Well, 4 squared is 16. What about radical 13 squared? Remember, a square and a radical, or a square and a square root cancel out, so that's just 13. So I apply this here, I get 16. I apply it here, I get 13. Then I have to multiply 16 times 13. So I get a squared plus 144 equals 208. Now, can I solve this? Sure. Subtract 144 over to this side. A squared equals, let's see, 208 minus 144, 64. Square root both sides. The square root of 64 is 8. If in doubt, check it out. So this opposite here is 8. Now I can do sine. Sine is opposite over hypotenuse. That's 8 over 4 radical 13. You can see that the 8 and the 4 will reduce, leaving you with a 1 and a 2. So that's 2 over 1 times radical 13. Here we have a radical in the denominator, which you're not allowed to do. So you've got to multiply by square root of 13 over square root of 13. That's 2 square root of 13 over square root of 13 times 13 is 169. 2 radical 13 over the square root of 169, which is 13, and that should be the answer. Oh, I guess I never checked number 9, did I? So let's check 9 and 12. 9 right there, 12 right there. And yes, I could have used the shortcut here, but I bet you're about sick of hearing my voice right now, so I'm not going to redo this one that's already done. So there you have it. The first page, all the numbers you need are given. You just have to set up the ratios, reduce if numbers can reduce, and rationalize the denominator if you ever have a radical in the denominator. So those are the skills you need there. On this side, you're actually going to have to do a couple more steps. You're going to have to do the Pythagorean theorem. Here, let me check numbers 9. Use the Pythagorean theorem, like 9 and 12, to find the missing side. Within the process of finding the missing side, you might have to simplify the radical using the factor tree. Then you set up your ratio, whatever it may be. Reduce if you can reduce. If you need to rationalize the square root out of the denominator, like right here, then that's what you do. So it's a whole bunch of skills all put together. If you have trouble, you have struggles, go back and re-watch a couple examples. You can also search on YouTube this topic, just trigonometric ratios. You can search Pythagorean theorem if that's something you're struggling with, because it's been a while since you've had to deal with that. And of course, you can use comments, or you can email me with questions. And I can even make follow-up videos if a lot of people have, issues on the same sort of thing. I'm not trying to make this sound terrible. I just know there's a lot of steps to it, a lot of things involved, and I'm just trying to prepare myself for questions. So good luck. Have a great day. Let me know if you have issues. Bye.